Students, good morning. Today's topic is Paxos algorithm. Definition. Consensus algorithm is in distributed systems are protocols that enable multiple computers in a network to agree on a single data value or decision to ensure consistency and reliability across the system, even though failures or malicious attack. Okay. So in network, if a group of computers are there, all the computers, that is all the nodes, should follow the leader's decision. Okay, leader will take decision and the followers should follow the decision of the leader. Okay, and this algorithm was developed by Leslie Lamport in 1989. It was designed to solve the consensus problem in the network of synchronous process. So what is a synchronous process? First, what is synchronous process? Means both sender and responder should be synchronized. For example, telephone calls. Telephone calls are the best example for synchronous process. Then what is asynchronous process? Asynchronous process, the sender and the reader need not be synchronized. For example, email. If we are sending email to our friend, he may see immediately the email, or he may see tomorrow or day after tomorrow as he likes, right? So in email, both the sender and responder need not be synchronized. Okay, and this algorithm is developed for asynchronous process. These are the features of consensus algorithm: agreement, fault tolerance, safety. Okay, fault tolerance means if one or two computers are crashed or failure, okay, it's not a problem with this algorithm. We can reach the final value. Okay, agreement, to algorithm aim to achieve agreement among a group of nodes regarding a single value or sequence of operations. All nodes in the system should agree on the same decision. So these are the features of consensus algorithm: safety, liveliness, quorum. Quorum means group, and this is a two-phase approach algorithm. Paxos and Raft are the two consensus algorithm used to achieve data consistency and fault tolerance in distributed systems. Okay. So these are the types of consensus algorithm. Crash fault algorithm. Example for crash fault algorithm is Paxos and Raft. And next one is Byzantine fault tolerant algorithm, proof based algorithm. Okay, and leader based algorithm. And leader based algorithm, there are two types: view stamped replication algorithm, multi Paxos algorithm. And if you take Byzantine fault tolerant algorithm, there are two types: practical BFT and determined BFT. And if you take proof based algorithm, these are the classifications. There are three types: proof of work, proof of stack, and dedicated proof of stack. And if you take that the voting based algorithm, there are two types. One is quorum based, another one is federated Byzantine agreement algorithm. Now come to Paxos algorithm. It's a process of agreeing on one result among group of participants, and it is a family of distributed algorithm used to reach consensus. Is also called a semi-synchronized method. So what is consensus? Agreeing on a single value. Assume there are four friends are there. Out of four friends, two friends want to go to cinema in the evening and two want to go to dinner. So they are unable to take a final decision or consensus. After some time, the person two also agrees to go to cinema. Now, majority of friends agree on cinema, so they decided to go to cinema. Finally, they reach the consensus, right? So this is consensus. Consensus means all should agree on a single decision. That is consensus. Okay. The same concept is followed in computer networks also. Here, one master computer will be there. Then slave computers. There will be a lot of slave computers. The slave computers or followers should follow the master computer's decision. Okay. That same concept is followed in network also. Master slave master slave network or active passive replication system, the same concept. Basics of Paxos algorithm: there are three rules are there. One is proposer, another one is acceptor, third one is learner. Who is proposer? Proposer is like a leader, okay, who initiate the decision value. Acceptors are representatives of learners. They vote for the decision to make a final one, okay, who contributes to reach a consensus. Learners who learn the agreed upon value and follows it. Paxos algorithm nodes take multiple roles, even all of them. A Paxos node run aims at reaching a single consensus. So it's a diagrammatic representation of Paxos algorithm. Step 1, prepare. The proposer will send prepare message to all the acceptors. Okay. Step 2, promise. The acceptor will send a promise message to proposer or leader. Okay. The acceptors send promise message to proposer. Then step 3, the proposer again send accept message to all the acceptors. You already promised to accept for a single accept for a highest message, the latest message you already promised, so you please accept it. In this way the proposer send message to acceptors. Then once a final decision or contestant is reached, then that message will be informed to the learners. That is step 4. So 3 phases: prepare, promise, accept. So the proposer will send prepare message to acceptors. Acceptors have to give reply to the proposer in the name of promise. They already promised to agree on the latest message. Promise means they should decline the older messages or earlier messages. They should only agree the latest or highest message. That's a promise. Okay. Once the proposer receives promise message from all the acceptors, the proposer will send accept message to all the acceptors. So once acceptor receives accept message, they have to accept the latest message. Okay. So proposer send prepare message to all the acceptors. So the acceptor has to give reply to the proposer, and once consensus is reached, they will inform the learner. These are 3 phases. Phase 1, prepare. Okay, go through the slides. Phase 1B, promise. Phase 2A, accept. Read the slide. If accepted, the acceptor has to set the value n comma b. The b may be z or x. If accepted, then we should set to z. If not accepted, then v should be set to x. Then finally proposer will send accept message to the acceptors. So if already promised, I will not accept if identifier number is less than n. If no such promises, so I will accept if the identifier number is greater than n. So what is the concept is, I should not accept the older messages that I already promised that I will never accept the older messages. I will only accept the message that has been received recently. Okay, that's the meaning. I promised, what I promised, I will never accept the earlier message. Okay, I accept the message sent at 1 p.m. Now 2 p.m. at 2 p.m. 2 o'clock, another message I received. So what I should do, I should ignore the message which has been sent to me at 1 o'clock. Now I should accept only the message recently, that is the message received at, now the time is 2 p.m. So what are the message I received now, that only I should accept. I should ignore the earlier messages. That is the concept, that is the meaning. Okay. Phase to be accepted. So that same one, message sent at 2 p.m., message sent at 3 p.m., message sent at 4 p.m. So the acceptor should ignore the message received at 2 p.m. the acceptor ignore the message received at 3 p.m. The acceptor should accept the message only received now. Now time is 4 o'clock. The acceptor should accept the message only received now. Okay, that is the latest message only the acceptor should accept. All other early messages should be declined or ignored. It's a diagram of Paxos algorithm. There are many pages, three pages are there: prepare page, promise page, accept page, and learner page. Okay, in the prepare page, proposer send prepare message to acceptors. In the promise page, acceptor have to send promise message to proposer. Then again the proposer send accept message to acceptors. So as they promised, they should accept the accept message, and once consensus is reached, they will inform the learner about the decision they have taken. So consensus is reached. Okay. Any doubt, ask me.